Welcome everybody. We're going to be starting pre-calculus out with functions. So let's see what a function is and how they work and do some problems with them. So first of all, a function is just a relationship where each input has exactly one output, and we generally write this as f of x. This f could be any letter, it could be g, it could be h, and x is just whatever variable we happen to choose. So really we could have a function that might look like this instead, right? H of a, for example. Okay, could be a function, but we generally look at it as f of x. Now there's a few parts to a function that we're going to start talking about. First is the domain. Okay, the domain really is just whatever input values, or the x values if we're looking at a coordinate system. Okay, domain is what we're allowed to put in. When we start talking about domain and range in more detail, there will be limits as to what we can put in certain situations. Okay, next is the range, which would be the output values or the y values, right? So we put something into a function, and whatever the function is, we get something out of the function. Now, range as well, when we get into domain and range, we're going to have limitations on what the range can be. For example, if we are working with a function that gives us even numbers as a result, our range would be limited to only evens. Okay, so it's domain is what we can put in, range what we can get out, and a function we can only have one output for each input. So whatever we plug in for the domain, we can only have one range output. So let's check out how that works with some coordinate pairs. Okay, in this first example, what we see is we plug in a 1 and we get out a 5. Plug in a 2, we get out a 10. Plug in a 3, we get a 15. We plug in a 1, we get out a 5 again. So when I'm looking at this, I'm checking to see, alright, if I plug in something in x, I get a y out. If I plug that same x in, do I get the same y out? In this situation, yes. So I have no x's giving me two different y results. So right now, this absolutely is a function. When I start looking at this next example, though, it tells me I plug in a, I get 6 out. I plug in a, I get 7 out. I plug in a, I get 8 out. Well, I don't know what a exactly is, but I do know that when I plugged it in here, I got a 6, and then I plugged in that same mystery value, but I got 7 out this time, and I got 8 out the next time. So I'm plugging in one value, but I'm getting something different out each time. That's no good. That doesn't happen with functions. So this is an L. So try pausing the video and check out problem C and D and see if you think that these are functions or not. Alright, let's check it out. So here we plug in 1, we get -2. Plug in 3, we get -5. Plug in C, we get -Q. Plug in 1, we get 5. There's the problem. We plugged in 1, we got -2. We plugged 1 in later on, we got +5. These don't match. No way is this a function. Let's check out problem D. I plugged in 5, I got 20. Plug in 6, I get 40. Plug in 5 again, I get 20. Plug in 9, I'm getting 80. Well, that 5 shows up twice, but both times I'm getting 20. So far, this one happens to be a function. Now, there's some other ways that we can check out functions, right? They're not just going to show up in coordinate pair forms. We might also look at them graphically. And we have a test that we can run for graphs as well. It's called the vertical line test. And when you're looking at a graph, if you can draw a vertical line anywhere on the graph and it intersects in more than one place, then the graph is not a function. In other words, if you draw a vertical line, it can only hit the graph once per vertical line. So let's see what some examples of this looks like. I think it makes more sense when you look at some problems. Okay, so here we have some sort of relation, right? And we follow it along. This is the relation that we're checking right now. What the vertical line test says is that if I were to draw a vertical line and it hits more than once on this particular relation, it's not going to be a function. So if I were to draw, say, a line here, on this example, we have a problem because it's hitting in multiple spots. And vertical line says only once per graph. So this is not a function because it hits more than once. And in fact, we can check multiple places and we're seeing it hit multiple times, especially right here where it's hitting a whole bunch of times. Okay. Second problem, right here, doesn't matter how many times I draw lines. These vertical lines are only hitting once every time. So this particular function, we would say, yes, this relation is a function. It's only hitting once per vertical line. Then we get some pretty crazy looking graphs, right? If I was to look at this one, now I'm noticing, well, it's hitting once here where that's included because it's filled in, and then it's going through this empty spot. Technically, it's only hitting once because this is like a hole. It's missing it at that point. So far, we're pretty good, right? And we can keep on drawing vertical lines until we get to about here, and then it happens again. Well, that's an open, so it's not included. This one's included. So far, we're doing fine, right? So we can keep on testing each of these graphs, and as long as it's only hitting once, we're in good shape, right? So that particular example, even though it's hitting multiple times, this doesn't count. It's an open, so this is a yes. So I've got 3 more. Maybe you can try them out, pause the video, and use the vertical line test to see if it works. I'll pause this and check it right after. Alright, let's see how you did with those. Okay, I'm looking at this spot right here for this problem D, and I should notice it's hitting once, twice, not to mention if I go back here even further, hitting twice here. This is no good. Okay, even further along, see the same problem. So is this a function? That one's a no. Okay, this particular function, things go well over here, things go well here, but then we start to run into problems around here, right? Hitting 3 times over here, a couple times over here. This is also a no. F, however, okay, I can draw lines. It's only hitting once. Going through here, it's only hitting once. I can keep on drawing vertical lines. Again, only hitting once. These are open spaces, so this one we're going to say yes. This is a function. Okay, hopefully you did okay with those 3. We've got one more topic to talk about, and that's evaluating a function. Okay, evaluating a function, pretty simple. All we're doing is we're substituting in whatever they're asking us to wherever we see an x in the function. Okay, so for example here, they give us a function, f of x is 3 times x squared minus 5. Now anywhere that we see an x here, we're just going to plug in what they ask us to. Okay, this one gives us 3 different problems to try. They want us to evaluate at 2, -8, and y. So we have 3 problems that we're going to do. First, let's evaluate at 2. So we have f of 2, and we usually write first what we're evaluating inside the parentheses. We know it's going to be 3 times 2 squared minus 5. Again, all I've done is substituted in what they asked. Alright, well that's equal to 3 times 2 squared would be 4 minus 5. 3 times 4 is 12 minus 5. 12 minus 5 is 7. So we would say in this problem f evaluated at 2 equals 7. Now we have f evaluated at -8. So we substitute in. We have 3 times -8 squared minus 5. That's 3 times -8 squared is 64. 3 times 64. Let's see. 12, 18, 19. 192 minus 5 is going to be 187. So f evaluated at -8. Okay, and the last problem they ask for is f evaluated at y. Well, y is not a number, but that's not a problem because all we're doing is just substituting in. So we would have 3 times y squared minus 5. Y squared is just y squared. So 3y squared minus 5. That's what happens when we evaluate at y. Okay, so we're going to try one more together. Okay, this time they give us f of x equals x plus 2 divided by 3. So again, whatever they ask me to substitute in, I'm just going to plug into the problem. I'm going to evaluate and simplify if I need to. So, first, f evaluated at 4. That would give us 4 plus 2 divided by 3. Again, just plugging in 4 for my x. That's the same thing as 6 divided by 3, which is equal to 2. So f of 4 in this problem equals 2. Next, we want to do evaluating at negative 17. So f at negative 17 is negative 17 plus 2 divided by 3. Negative 17 plus 2 is negative 15 divided by 3. That's going to give us negative 5. So f value at negative 17 is negative 5. One more. Here we have 3z. So we've got f evaluated at 3z equals 3z plus 2 divided by 3. Well, I can simplify this. I'm going to break this up a little bit. 3z over 3 plus 2 over 3. I hopefully notice my 3's will eliminate. So f evaluated at 3z, we're going to get z plus 2/3. So there's one more problem for you to try out right here. Pause this video, test it out, see what you get for those 3 values. Okay, let's check out how you did with these. First, we're going to do f evaluated at negative 2. So we have negative 2 squared plus 10. Negative 2 squared gives us 4. Plus 10 is 14. Next, f evaluated at 10. That would be 10 squared plus 10. 10 squared is 100, which means that f evaluated at 10 is going to give us 110. Last, we have f evaluated at 2a. So that means 2a squared plus 10. Here we have 2a squared. That's going to be 4a squared plus 10. We can't go any further with that. That is our solution. Okay, so those are functions defined. That's how we evaluate. Again, vertical line test, easy to do. You just check to see if any lines hit more than once. And as far as coordinate pairs, again, if we have one x value giving us multiple y values, doesn't work as a function. Okay, see you on the next video.